So, hello, good evening, guys. Hello, everyone. Can you guys confirm that we are live? Then we're going to study, today queues and stacks and queues. And yesterday's, what you learned. We'll just, do revision once. Okay. Good evening, all. Good evening, all. Good evening, Sita. Good evening, Kamil, Shreya, everyone. So, can you guys confirm that we are live? Can you guys hear me properly so that I can go forward with it? I'll share my screen afterwards that. Hello everyone, Sita. Can anyone confirm in the chat, please? Can anyone? Okay, great, Shreya. Thank you. Thank you, Shreya. I'll share my screen. So today's topic is very important data structures we're going to learn today. So that is what is stack we're going to learn, stack and queues. So yesterday we learned till, we learned what? Yesterday we learned linear search and binary search, right? And linear search, binary search, searching algorithm we saw, and we saw what? Sorting algorithm. One sorting algorithm is selection sort. Okay, I'll just revise once. Okay, linear search and that is also called a sequential search. We saw that we took an example of what? We took an example of that if a book is unsorted, like if its page doesn't start from zero, like it is starts from wherever page it is, correct, like 34, 35, 36, 37, correct. So what will happen is it will become very difficult to find those words. If suppose you have dictionary and its page number or it's not written in alphabetical orders or whatever orders, so it will be very difficult if dictionary of page 2000, 3000 pages, then for finding one particular word you'll take tons of time. So that's an issue, isn't it? So that's why you don't prefer to do linear search, because it can be done, linear search can be done for sorted array also, unsorted array also can be done, but we saw for the unsorted array, correct. But one thing is for linear search, that basically we give the key and it compares with every element there in that array and try to find if that key is equals to that whatever there in the array or not. If it is equal, then we say it is there, or if it is not equals to that key, nothing there, so we cover that case also in the else, and we say that it like that key is not present. Okay, great. This is the thing we learned, and we saw that like if you have to search for huge database like Google, I talked about Google searching thing, correct. So when you search for a string, so you basically write words, right? We saw for the integers. So basically when you write words, so if you search something on Google and it takes tons of times, so that's an issue with that search engine, right? So no one wants to that's why people switch from Yahoo to Google, because Yahoo is way more complicated, its homepage was way more complicated, but Yahoo came first before way more before than Google, but still people switch to Google because their efficiency of searching and all those stuff was very fast and efficient. That's why after that what we studied, what was that? Binary search. Okay, in binary search what we learned is, like we will take an array, so we'll take an sorted array, correct. in binary search, what was our idea? That we'll take an sorted array. First, the array need to be sorted. For that sorted array, how to sort? We already saw one sorting algorithm also. That is, so selection sort, correct? So that we, for that also we'll talk about once. Okay. In binary search, what we saw that here एक array रहेगा. So its indexing will be starting from 0 because it is an array, correct? And it will have like will give some value, like we give some variable name as the first element names to be start and last element to be end, and some key will be there, and we need to find it if that key is present in that array or not. If it is not, then it will return that key is not found. Okay, so that is the thing we need to do. Our thought was, so one thing is we have to we found what middle element. Then after finding middle element, we compared that key with middle element, if it is equals to middle element or not. If it is equal, then we'll say, okay, we found the whatever we are searching, whatever number we are searching, we got the element. If it is not equal and less than middle element, it means what? It will be lying left side of that array. It means that, right? Or else it will be right existing where? Right side of the array. So we declared what? Middle element, and we covered 3 cases. If 3 conditions we covered, right? So we written a binary search and we pass that array, inside that, and start, end, and key, key that we have to search, correct? So we found the middle element. Before finding middle element, we run the loop till while, till when. So it need to run in a loop, right? So we written a while loop, and there we gave the condition is start is less than equals to end. What does this mean? Start will always be less than or equals to end. So start is what? 0, end is 7. So end is every time is going to be greater than or equals to. When it will become equals to? When this becomes start and this become end. It means the array has only one element. So that time this equals to condition satisfies. Okay, great. After that, what we saw, that we found the middle element. We know middle element how to find. Start plus end divided by 2. That is middle element. We take the floor value of it. So that is whatever the middle element coming. Then we write the if statement. In that we say array का middle element अगर key के बराबर है, so return true. So return true. That return 1. और अगर नहीं है, else if अगर नहीं है. So yesterday I told you that you can write else if also or if also, if like doesn't matter. Okay, so you can write else if also, that's okay. Okay, so अगर key बड़ा है middle element से, if key is greater than middle element, it means the key is lying here, right? So we need not to search here. So we need not waste our time or memory here by searching left side of it, of the middle element. So we'll search it here. So like what starting end will always be this one, and starting will be this 50. From here I have to search. So what is the start I'll give? Well, what is the value to the start will assign? Start equals to mid plus 1, isn't it? So here what we'll write? Start equals to mid plus 1. Else अगर यहाँ पर नहीं है, इसका मतलब लेफ्ट साइड पे, क्योंकि ये मिडिल वाला एलिमेंट तो हमने कवर कर ही लिया ना. मिडिल वाला एलिमेंट तो हमने यहाँ पर कवर कर ही लिया. ये एक हमने कवर कर ही लिया मिडिल का. ये कर रहे हैं राइट के लिए, ये कर रहे हैं लेफ्ट के लिए. अगर कुछ नहीं है, अगर उसमें की है ही नहीं, तो इसके लिए ये भी हमने फॉल्स रिटर्न कर दिया. तो ये बेसिक एल्गोरिथम था उसका बाइनरी सर्च का. ओके, सो this was done. Then selection sort हमने पढ़ने की कोशिश करी थी. Selection sort was what? It is basically a sorting algorithm. Basically you give random numbers to an array, and it will you can sort in ascending order also, descending order also. So you have to, I'll show you, like yesterday we saw what? In ascending order, correct? But we can do descending order also. Just you have to change the sign of it. That will take you to the descending order. Okay, great. So what we saw in selection sort, that first element would be considered as the minimum element. Then we'll store that element's index to minimum index. Then we'll move forward from here. Next index We'll run another for loop. From here it will run and we'll try to find the minimum element of it. And whatever the minimum, suppose 2 is the minimum element, correct? Then we'll compare 2 with 9. If it is less or something, then we'll swap it, correct? So 2 will go to here, this position. If it is not smaller or something, then it will not swap. So that is the algorithm we saw, right, yesterday. So you remember, so we consider that first index to be 2 loops we written, outer loop, then inside that loop, outer loop was what? Considering 0, 1, 2, 3, every element, 0 for 0th iteration, 1 first iteration, second iteration, the outer loop. Inner loop will start from here. So that's why you written j equals to I plus 1. It means it is starting from 36. So from here it will find the minimum element, that is 36. 36 will be compared to 50. So if it is less than or not, if it is less than, so we'll, update it, then we'll swap it. So that's what we saw yesterday, correct? Now today's topic is, we'll move forward with what? We'll move forward with stacks and queue. So I have to jump to, 140 slide. So today we'll cover this a very important, concept, that is, what is stack, correct? So stack is a data structure. So yesterday what you learned, linear search, binary search, sorting, those are algorithms, okay? So basically DSA, data structure and algorithm. So lots of data structures are there and lots of algorithms are there. What are the different types of algorithms are there? Recursion, dynamic programming, then searching algorithm, sorting algorithm. In sorting, lots of there, whip sort, quick sort, merge sort, all those stuffs are there. In searching algorithm is also there, linear search, binary search, all those stuff. Lots of algorithms are there, and lots of algorithms are nothing, just step-by-step process to solve any particular kind of problem. So that is what algorithm is. Data structure is nothing, structuring data in such a way that whenever we need something, we can access it fast, we can access that data fast, very fast, okay? So that is what data structure is. So similarly, one data structure is there is what? Stack. So stack is a data structure. Basically, for array, we saw the insertion, right? So there we can do deletion also. Similarly, that we do for the insertion. So in stack, there are a few terms are there. Few functions are there. That is called push, pop, is empty, is full size. These are the functions are there in a stack. So what does those means? Like, so basically, push is the insertion operator. We say that push is an insertion, or when you want to insert something in a stack, that is what that time we use push. And when we want to delete something, that time we use pop, correct? So this push and pop, like when we can enter, suppose take an example, you have bucket in your house, right? So we were going to implement stack using what? Array. So stack can be implemented using linked list also, correct? So, but okay, I'll tell you one thing about difference between, okay, lots of things are there, right? So I'll just confirm. So I'll guys get you there. Like, what is the difference between, arrays and linked list? Just an overview. So array is a data structure that stores values. Linked list is also a data structure that stores values. Okay, both are same. Okay, then why need a linked list and why need array? Okay, so there are a few differences are there. So here we're going to implement stack using array because we learned array. That's why. Okay, so array size is fixed, but for linked list, size is not fixed. You can change the size of a linked list in a runtime. It means anytime you can change the size of the linked list, and you can give what? You can give space in the heap, wherever that heap memory in the memory structure. Okay, so what is the thing? That one more difference is stack has what? Continuous memory allocations are there. We learned, right? If first block, 0th index have 1024 as the static, that address starts from 1024, then next will be 1028 definitely, then next one will be 1032. But for linked list, that is not true. So it can randomly take any space in the RAM and just link it, and everything will be done. So that I'll give you analogy to it. Okay. So you guys have buckets in your house, right? You guys have buckets. So that bucket size, if it contains today you have bucket in your home, and if that has capacity of 10 liters of waters, tomorrow also it will have like capacity of 10 liters of waters. It means the capacity it going to cover, can contain water, is going to remain fixed, like whether today, tomorrow, or day after tomorrow. But for linked list, the capacity can change. So that's an ideal bucket that can change according to your need. So if you are pouring some more water on it, no, its size will grow accordingly. So that is what linked list is. That's how you can correlate to it. But in an array, if you want to put more, it will like just overflow it, correct? So we going to do what? Stack. We going to apply stack using array. So stack you consider as a container, and inside that what thing will be storing? Data will be stored where? In the array. Okay, so basically it means stack size is fixed. So you guys have heard about that very popular website, that Stack Overflow, correct? So what is that is, when Stack Overflow means what? Stack Overflow means, this is stack is there. So its size is depends on array size, because we are implementing stack with array, correct? So here array size of 4 is there. It means stack is also having size 4. So it cannot store more than 4 elements in that stack. So if I want to enter more elements, suppose here I want to enter more elements here, so it will just overflow. So that is what is called as stack overflow. It means memory का बहाव हो गया, ज्यादा मेमोरी डाल दिया तो वो मेमोरी लेगा नहीं, तो स्टैक ओवरफ्लो हो जाएगा. So that is the meaning of stack overflow. Are you guys getting it? So this is the thing. So can I see in the chat? Okay. So today's lectures is it's stacks and queue. Today's lecture is Sahbaz. Today's lecture is stacks, and you can see in the like DBMS we like, okay. So we'll request to our team that to teach DBMS also, but today we are going through DSA. So that is what we are going through. Okay. So I'll ask the team to teach DBMS. Okay, great. Yes, Sita, he should have checked the thumbnail and Okay, great. Moving forward. So that is what. So where is the implementation? Suppose you go to Google. So where stack is used basically. So when you go to Google.com, you go to browser and you write www.google.com. So that is getting stored in the stack. After that you move to there you write let's upgrade, suppose. So that is also getting stored in the stack. Are you guys getting it? Then you move to that website letsupgrade.in, correct? Then that is also getting stored in the stack. Then after that, few programs are there, data science program, web development program, you click on that. So that is getting also stored in the stack memory. Now stack is getting full. If it is of 4 size, then it got filled. So if you try to click more, so it will not get, get filled. So how that, stack, so in a stack, one main thing is everything, allocations and deallocations happens automatically. What I mean by this is, when you study about dynamic memory allocation, no, that time you will understand this thing what I'm saying, that stack get memory allocations and deallocations happens automatically. For dynamic memory allocations, there you have to allocate dynamically, then you have to deallocate also dynamically. So that is there. So when you go to forward to that step, then you will understand what I said here right now. Right now you don't have to focus this thing, but what happens is, in a stack we cover LIFO, last in first out. So whichever came last, so this should have come first, then let's upgrade, then let's upgrade.in, then this. So we are basically, what we are doing, we are just going to Google, and here I am writing google.com, then let's upgrade, and all those stuffs I am writing, correct? So that is what it is doing. It is storing in the stack. Now when you click on the back button of a in the browser, so that time it will, if you wants to come back, so it will just delete this one. Then you come here, let's upgrade .in, then you again click on the back button on the browser, then it will come again back to back side of it, then it will get deleted. Then again you click back button, then this is deleted automatically, it gets deleted when you click on the back button. Okay, then this is also gets deleted when you back button. Then you come to where, then you come to the the initial home page of the browser. So that is the application of stack. Or you can see stack is suppose here I'm doing, suppose this one, Control C, and I pasted here. So if I do Control Z, no, this is undo. Control Z, it is going. This is also getting, I'm putting in the stack, then it is getting deleted. Like when I'm pressing Control Z. So that is also, undo thing also is, that is stored in where? In the stack. Okay. Now we have to implement using what? Numbers. We're going to push some numbers to it, and we some delete, that is pop. Push is what? Insertion operator in a stack. Insertion operator in a stack is called push, and deletion operator in a stack is called pop. So I am teaching the stack very detailed, so that when I teach you queue today, so stack is very similar to queue. So there we follow different, you will guys get to know what we follow there. Here we follow what? LIFO, last in first out. It means this came last, first came this one, second this, third, fourth, right? So this came last, so this will be deleted first. Last in first out means what? This came last, so this will be deleted first, then this will be deleted, this will be deleted, then this will be deleted. Correct? So this is the thing. So we're going to implement stack using what? Array. Okay, what I said. One more thing, we consider one variable as a top variable that will iterate through the the stack and say whether stack is full, that is empty, or that is something you can enter the value, or you cannot enter the value, or it is empty. That is going to covered by that top variable. If top is -1, so top 0, it starts from here. Array of 0th index is this one, then third index. So we also consider top 0 is this one. So top equals to -1 means what? This stack has nothing, the stack is empty. So we'll say when top equals to -1, it means it has nothing in the stack. So that is one thing. So top variable will introduce there. Okay. Now one thing, is stack full? 2-3 functions are there. Is stack full and is stack empty? So अगर बताओ यार, अगर ये स्टैक पहले से फुल है तो हम क्या यहाँ पर डाल सकते हैं कि नहीं? कोई वैल्यूज, कोई एक्स्ट्रा मेमोरी यहाँ पर हम एलोकेट कर सकते हैं? नहीं कर सकते, क्योंकि वो पहले से फुल है, तो उससे स्टैक ओवरफ्लो हो जाएगा अगर हम डालने की कोशिश करेंगे. नहीं, तो that is not possible. So we will write that function, is stack full, if stack is full or not. Correct? If stack is full, we cannot enter. We'll return that you cannot, stack is full, you cannot enter the value. If it is not full, then we'll enter the value in the stack. Correct? So similarly, if stack is empty, we cannot delete it. Pop is what? Deletion operator. We cannot delete it, right? If stack is empty. Correct? So we cannot delete it, isn't it? If stack is empty, we cannot delete it. So it means what? It means what? We will consider that thing in stack is empty. That function will cover that thing. So what will we be writing in the push function? Basically, we'll check if the stack is full or not. If it is full, like we cannot insert the data, isn't it? Otherwise, what we'll do? If it is not, if the stack is not full, suppose this is not there, suppose. Okay, let me delete this one. Control X. Suppose let me delete this one. So this stack is not full, right? So what I have to do? Top 3 is not there that time. It means I have to increment the top variable and I'll enter the value here, isn't it? It means incrementing. So when I'm adding value, it means adding what? Incrementing the top, isn't it? When I delete something, suppose I want to pop, that is deletion operator in a stack. So when I have to delete this one, it means what? top 3, like top variable value is 3, right? That is iterating, right? So we have to decrement to what? 2, isn't it? If I delete this one, it means I have to decrement the top to 2, isn't it? Now this will be empty. Now if I delete again this one, so it will decrementing, isn't it? So what it is saying, when we want to push, we will increment the top variable. When we delete, that is pop, so we have to do what? Decrement the top variable. So that is the whole logic of it. Can you go forward and write the code, write in the code? So okay, so you can go forward to the one link, click on the you to submit the assignment, you can go there and click on the one link, and you can mark attendance, and you can submit all the stuff there. Okay, go there and do the stuff. Thank you, Banshika, you for the help. Okay, moving forward, we'll go forward with the what, that how to implement a stack. So I'll delete this one. So I'll write implementation of a stack. Implementation of a stack. So क्या क्या देखा हमने यार? एक pop function रहेगा, एक push function रहेगा, एक is empty, is stack. So 2-3 functions will be there, right? So we going to do what? We going to implement using what? Array. So suppose I'll declare an array, int array of, suppose I declare with 6, array size is 6, and what I said, that will take top variable, and that will be initializing with -1. It indicates what? That declaring an array size 6, top variable to check if stack is empty, full or not. These other things will be done like that will be done for iteration of this one. So okay, first thing we want to do is push. We want to enter the data. So for pushing, we have to check if stack is full or not, right? We have to check if stack is full or not. Otherwise, if it is full, we cannot enter the value, isn't it? If the stack is full, we cannot enter. So for the push function, we'll do the one more helping function will be there, is what? So that is what is stack full. So we'll declare and we'll write a function, so that is what is stack what full. So we'll write a function is stack full, and inside that we'll write a function is stack full, and inside that what I'll be writing, if top is equals to what? If top is equals to 5. सही बोल रहा हूं कि नहीं? यहां पर क्या बोला था हमने? एरे साइज क्या है? 4 है, बट टॉप क्या है? एट द लास्ट 3 है. इट मींस बिकॉज एरे स्टार्ट फ्रॉम 0th इंडेक्स, इजंट इट? सो जब 3 होगा तभी तो स्टैक पूरा फुल होगा, नहीं? So that's what we are writing, because array size we taken what? 6. So top will be what? If 5, if top is 5, it means what? It is full. So you cannot enter the value, isn't it? So if stack is full, if stack is full, function we're writing, if top is equals to 5, it means it is full. So we cannot enter the value into it. So I'll return 1, and I'll cover this thing in the pop function. I'll write the stack is full, you cannot enter the data. So that is the thing I'm going to write, return 1, or else at the for because it's of integer type, so it have to return that execution, right? So I'll be returning at the last is 0, return 0. Okay, this is stackful. This is the helping function. This is helping function for pushing or insertion कह सकते हो, insertion, helping function for pushing pushing oblique insertion. Okay, helping function for pushing oblique insertion. So this is the helping function. Now I'll write for what? Actual function, that is push. What I'll write here? I'll be writing I'll be writing it as, we'll take the value integer val, that will be entered from the main function that there will be doing. This is what? Insertion in a stack. Insertion in a stack. Okay, great. So in the push function, what I'll be writing? I'll be calling this function if if this is true, returning true, right? So what I'll be saying, by see out कर दो कि ये see out कर दो भाई कि stack is full, you cannot enter more values. So that it will print, because when I call this one and it will go here, and if top equals to 5, it will return true, isn't it? So return true means here from line number 22 it will jump to where? Line number 14, because calling of function is happening. So it will go here and it will try to execute this if statement. If it is true, then it will come back here. If it is not, that will also will cover. Okay, and I'll write what? And then and else. Okay, not endel. Stack is full, you cannot enter more value, and I'll give what? Value also here, that whatever the value is, isn't it? Endel. Okay, then else part, what will be writing? In else part, what will be writing? That we can now enter the value. So what we used to do, if some empty space is there, we'll increment the top and we'll put the value, right? So I'll increment the top by what? Top plus plus. So I incremented the top. Now हम ऊपर पहुंच गए, यहाँ पर खाली है, अब वहां पर वैल्यू डाल दो भाई. अब ऊपर पहुंच गए तो कैसे डालेंगे? एरे ऑफ टॉप का में वैल्यू डाल दो. So ये डाल दिया वैल्यू. So this is the whole function covering for, this is the whole function covering for what? Pushing, insertion of data. So ये कहाँ से आ गया? ये किसी के, okay, this is with that one. Okay, great. Now we'll go forward and write for what? Pop function, isn't it? Helping, then again we'll write this helping function for pop मतलब क्या है? Deletion है कि delete करके दिखाओ भाई, deletion. Now again I'll write the function that integer type, its data type is, return type is integer, and I'll see is stack what? Empty. अगर empty है तो delete नहीं कर सकते ना. अगर empty है तो हम delete नहीं कर सकते कुछ भी इसके अंदर से, ऐसा ही तो है. So if when I said it is empty, top equals to -1, अगर top equals to -1 है ना, तो ये empty है. इसका मतलब यहाँ पर क्या करो? रिटर्न कर दो what? 1, और at the last list of integer types have to return, so return 0 कर दो. RN return 0 कर दिया भाई. चलो ठीक है, बढ़िया. Now this is the helping function for what? Helping function for pop. Now I have to write the pop function. I'll write pop function void pop. Okay, great. I don't have to take any, because we want to just delete it. So we don't have to take any, here we take a value, that is we want to insert, correct? So that we get to take value from either we can take value from user or we'll directly write in the main function. So okay, so this is the pop. Okay, great. Now what I have to do is I have to call the function, isn't it? If stack is empty, so it will return okay, stack is empty, you cannot delete more, correct? और अगर empty नहीं है तो delete कर सकते हो, तो उसके बाद क्या करेंगे, decrement कर देंगे top को और value बोल देंगे ये delete हो गया value. So I'll call that function is stack empty, so I'll just copy it and paste it, and this is calling of function happening, isn't it? So after that what I'll be doing, for after this what I will be writing, I'll saying that cout key stack is empty. मतलब कि इसको डिलीट नहीं कर सकते यार, पहले से एम्प्टी है और मत डिलीट करो भाई. अगर ये एग्जीक्यूशन हो गया, ये वाला लाइन टॉप इक्वल्स टू -1, टॉप इक्वल्स टू -1 मींस व्हाट, यहाँ पर लाइन टॉप इक्वल्स टू -1 लाइन हियर, top 0, it start from 0, but it means what, nothing is there in the stack. So that time return what, -1, return back here and it will say stack is empty. Else what we'll do, else part I'll say cout popped element is, what will be the popped element, the top of it, isn't it? So I'll write array of top. So that is the element we are popping, right? And at the rest I will write endel. So this, and what I have to do, I have to decrement the top also, isn't it? So I will decrement the top minus. So this will decrement, come below to it, correct? So this is the whole function writing of this is done. Okay, great. Now let's see, anything we have to cover, anything. This is the insertion of a stack, and I'll write what this is as the deletion in a stack. Okay, so this is the thing. Now main function में हम या तो इनपुट यूजर से ले लो या डायरेक्टली दे दो, हम डायरेक्टली दे देते हैं, चलो कोई बात नहीं. सो सपोज आई वांट टू कॉल दिस फंक्शन पुश, इंसर्शन यहीं पे करेंगे ना, तो पुश और कुछ डेटा देना है, तो पुश आई विल राइट एंड आई विल एंटर सपोज 89. ओके, तो हम कितना वैल्यू दे सकते हैं, साइज क्या है, 6 है. 6 से ज्यादा दे देंगे ना तो उसको बोलना चाहिए कि स्टैक फुल है, यू कैन नॉट एंटर मोर वैल्यू, यू कैन नॉट एंटर मोर वैल्यू, दैट इज दैट वैल्यू यू कैन नॉट एंटर, करेक्ट. सो अगर मैं 89 डालता हूं तो ये एग्जीक्यूट करना चाहिए, ये एग्जीक्यूट कर रहा है, कुछ दिख नहीं रहा भाई, क्योंकि हमने प्रिंट नहीं करा, हमने कोई प्रिंटिंग फंक्शन नहीं लिखा. कल हम प्रिंटिंग फंक्शन लिखे यहाँ पे प्रिंट कर रहे थे ना, तो वो ट्राई कर सकते हो, वो तुम ट्राई करना, ठीक है. बट एक डाला, कुछ प्रॉब्लम नहीं आ रहा, एग्जीक्यूशन हो रहा है, ठीक है. 89 प्रिंट क्यों नहीं रहा भैया, क्योंकि हमने प्रिंट करा ही नहीं, हमने प्रिंट फंक्शन कोई लिखा ही नहीं. यहाँ पर प्रिंट फंक्शन लिख के यहाँ पर कॉल कर दो तो फिर हो जाएगा, वो भी काम हो जाएगा, बट वो तुम ट्राई करोगे. तो यहाँ पर मैं करके दिखाता हूँ. 2 डाला, ठीक है, फिर 3 डाला, 4 डाला, प्रॉब्लम नहीं आना चाहिए, 5 डाला, क्योंकि एरे साइज क्या है, 6 है, तो 6 तक तो हम डाल ही सकते हैं. तो अगर ये 5 रन करके देखते हैं, सपोज को मैं वैल्यू चेंज कर देता हूँ 67, लेट मी चेंज द वैल्यू ऑफ दिस थिंग्स, 89 नॉट 89, 56, 87 and 34. So 5 values are there. If I run it, it is perfectly running, nothing is printing because we didn't write the print statements, Now again 6 values I've given, I write 90. If I run, it is still running, क्योंकि हम पुश कर पा रहे हैं स्टैक में, हम एंटर कर पा रहे हैं. इनिशियली सपोज कोई वैल्यू नहीं था तो हमने क्या डाला, इनिशियली कोई वैल्यू नहीं था तो यहाँ पर क्या डाला हमने, 89, देन 67, देन 56. और ये क्या फॉलो करता है, ये लिफो फॉलो करता है, लास्ट इन फर्स्ट आउट. सो लास्ट कौन आया इसमें लास्ट कौन आया, 90 लास्ट आया, फर्स्ट कौन आया, 89 आया, राइट. सो नाउ सपोज आई वांट टू एंटर वन मोर वैल्यू, सपोज एज 76. अब इसको एंटर नहीं होना चाहिए क्योंकि यहाँ पर कितने आ गए, 1 2 3 4 5 6 7, बट आवर एरे साइज इज व्हाट, 6. So it should return this statement, isn't it? Stack is full, you cannot enter more value, then value number will be printed, that is what, 76. If I run this one, You see, stack is full, you cannot enter more value 76. Correct. So now I'll comment this one. Now do what? We'll try to delete. These things. So what will be deleted first? Last in first out. जो last आया है वो पहले जाएगा. तो what will be deleted first? Deleted first will be 90. So let's run the pop function. So one pop function I do. So popped element is what? 90. Are you guys getting it? Popped element is what? 90. हम डिलीट भी तो 6 तक ही कर सकते हैं, उससे ज्यादा डिलीट कर देगा तब तो बोलेगा कि यार स्टैक में कुछ है ही नहीं, डिलीट क्या करोगे. सो इफ आई कंट्रोल वी तो पहला एलिमेंट क्या डिलीट हो रहा है? 90. देन 34 डिलीट होगा, देन 87 डिलीट होगा, 56 डिलीट होगा, क्योंकि लास्ट इन फर्स्ट आउट. सो दैट विल बी फॉलोड. आर यू गाइस गेटिंग इट? ओके, ग्रेट. If I do these 4 things, so 90, 34, 87, 56 should come. 90. Yes, it is coming accordingly. 90, 34, 87, 56. Now I'll do both. I'll copy this one, suppose. Copy and paste it here. And paste it here. So 6 हम कर चुके, इसका मतलब स्टैक एम्प्टी हो गया. इसके बाहर हम नहीं कर सकते. ये देखो 6 इसने ये 6 एलिमेंट्स, क्योंकि ये हमने डाले थे स्टैक में, ये 6 एलिमेंट इसने पॉप कर दिया. दिस लाइक डिलीटेड ऑल द एलिमेंट्स. नाउ स्टैक इज एम्प्टी. नाउ इफ आई फर्दर वांट टू डिलीट द एलिमेंट, will it, what will happen? You see, it is saying a stack is empty. It means this is running. Now top is equals to 6. This time what is happening? Like, top is equals to -1. That is what? Stack is empty. Top is equals to -1. That is why it's returning 1. So 34 line to it is coming to 42, and it is printing stack is empty. Okay, guys? Okay, great. Now this is the whole concept of stack. Similarly, we'll go forward with the queue. So queue is also similar thing. Only one thing I'll show the difference, and you guys will get to know. Okay, I'll have to change to C++17. Okay, queue is also same thing. Just one difference is there. We'll introduce 2 variables. So herein what we studied, last in first out, right? So implementation of queue. So first of all, I'll go forward with the theory first. So I need to jump to what? 174 slide number. Okay, so queue is a data structure which is like, it's very common, right? So in our day-to-day life, we stand in a line. So that is what queue is. Correct. So in a stack and queue, what I said, both are very similar. Here what we have to consider is first in first out. जो पहले आया उसको पहले निकालो. यहाँ पर लॉजिक चेंज होगा. Logic will change here, and there in the stack we used to take top variable, right? That is going to iterate through. But here we'll take front and rear. Here what will take front and rear. Front will be the first one, rear will be the last one. Are you guys getting it? So we'll iterate front to delete thing, and and we'll iterate rear also to do those stuff. So in stack what we said, for insertion, what do we use in a stack? Push. For insertion in a queue we use NQ, name change, NQ. Okay. For deletion in a stack, what we use? For deletion in a stack, we use pop. For deletion in a queue, we use DQ. Now same thing, is queue full or not? We'll check. अगर queue पहले से full है तो उसमें enter नहीं कर सकते हम value और, right? So that will be the helping function of NQ, isn't it? So is queue empty or not? So if it is already empty, you cannot delete from the empty. So this is the all similarity with the queue. So this is going to implement this one. Okay, so this is going to be implemented for what? Q. Same thing as stack. So we're going to use what? For Q also we're going to use array to implement, like so this is all the thing, like same and the similar thing, only two thing will introduce, and rear and front, and we'll just iterate front, because here I have to consider is first in first out. This is the thing difference in Q. So whatever come first, suppose 25 come first, then 56, 78, 90. So there is to delete 90 first, but here I have to delete 25. So here is the logic part will be changed. So here is one logic will be changed, that I have to delete that thing. So can we go forward with the Q implementation of Q? Can you go forward? So I'll try to explain more here. Okay, I'll try to explain more here when I write the code. So here what we did, I show that I could have used macros here. I could have used macros here, hash define. You remember, for 2-3 classes we use macros, hash define and size equals to. So we didn't use, we directly write the directly write the what, the number, correct? And here we top equals to 5, because arrays start from 0, so top 5 will be the top element, isn't it? So now I'll show you, I'll try to show you with macros also, once again. Okay, so that you guys get everything, like what essence of all types of programming. Okay, so I'll write size equals to, suppose I give it as 6. So this size is going to remain constant for all of the code we write. Okay, ye kya ho gaya, size equals to 6. Okay, great. Now what I have to write, I have to define an array, right? I have to declare an array. So I'll declare an array arr of what? Size is what? Size. I could have written 6 directly here. I'll write size because I'm using macros. Okay, this is what? Declaration of array. Okay, we declared the array. नाउ हमको क्या करना पड़ेगा, एक एनक्यू फंक्शन बनाना पड़ेगा, उसका एक हेल्पिंग फंक्शन रहेगा, एक डीक्यू फंक्शन बनाना पड़ेगा, उसका एक हेल्पिंग फंक्शन रहेगा. एनक्यू फंक्शन में हम ये चेक करेंगे उसमें और इंसर्ट कर सकते हैं कि नहीं, तो उसके लिए चेक करना पड़ेगा स्टैक इज फुल और नॉट. इफ इट इज फुल वी कैन नॉट एंटर बिकॉज इट्स ऑफ array, we are implementing with array, so we array size is fixed, we can enter more elements there. So that is going to see. So what I'll be doing, okay, two things I have told, right? That front and rear will be there. So I'll be initializing front and rear with 0. We'll consider that it is starting from here. Front will also be pointing here, rear will be pointing here. It means it is initially it has 0. So I'll be initializing with 0 to front and rear. Two variables are there, right? So I'll define two variables in front. You can write anything name. You can write your name, my name, anyone name in place of front or in place of AR. This is just array name. You can write anything. This is size. You can write anything. So it depends on you what you try to write. So I'll declare, like I initialize value front with 0. So initially it has nothing. Int rear equals to 0. I initialize this with also 0. Okay, great. Now I have to write the helping function. I have to write the similarly here, write helping function for pushing or insertion. Similarly, I'll be writing helping function for whom? Helping function for Q. Helping function for what? NQ, ENQUEUE. Or insertion, same thing. So what I have to write? I have to declare, I'll declare the function name is Q what? Full. अगर Q full होगा तो रिटर्न कर दो कि ये full है, अदरवाइज में एंटर कर सकते हो. That is what the thing is, correct? So what I'll be writing? कब कहेंगे कि कब कहेंगे कि क्यू फुल है? यहाँ पर हम कहते थे टॉप इक्वल्स टू 5, इट मीन्स व्हेन इट इज गोइंग टू द लास्ट, राइट? सो दैट टाइम इट इज व्हाट? फुल. But when we say queue is full, when this front will go, front will iterate here, array size, suppose array size is 4, so front will iterate to here and here, and front equals to rear it becomes, that time we will say that, right, that queue is full because front reached here. Front, we are iterating front and rear to check whether that is full or not. So what we'll say, what is the condition here? We're going to write if rear equals to front. अगर rear front के नहीं will say अगर rear size के बराबर हो गया, चलो ये size 4 है, rear initially कहां पर है? Rear is initially at 0th position, front is also in the first 0th index. Where is that? So if array size is 4 and it entered the last position, when it will goes to the last position, when it will go to the size of that array. So if I say rear is equals to size, it means what? Q is full. Q is full. So I'll return 1. It means full. Else I'll return 0, that will be covered. So this is the helping function for the enqueue. Now I'll write enqueue function. And this will be covered here, like we'll be printing here, we'll be calling this is queue full. Then if it returns this one, it will print that. Otherwise, if it returns 0, it will go to that part. So I'll be writing function that is, suppose void enqueue, and I have to enter the value, right? Int value. I have to enter the value enqueue. So this is now I've entered the value what I have to enter, right? So what I have to do, I'll call that function if queue is full. If queue is full, तो क्या करना पड़ेगा? If queue is full, अगर ये full rear equals to size हो गए, returning 1, that time do what? That time print that queue is full. That time write what? Queue is full. So यहाँ पर तुम ये curly braces भी दे सकते हो ऐसे करके, फिर ऐसे, but I am not giving it because only one line is there, no, so I don't want to complicate, that's why I'm not writing it. Okay, so else, in else what I'll be writing, I'll give the value, else we can enter the value, isn't it? Else array of rear जो part होगा वहां पर value डाल दो, enter the value there. So that is what I'm going to do, and I'll go like I'll enter the, suppose this is not filled, suppose, correct? So this is not filled and rear is pointing here, so it will be filled value, then I'll increment the rear to here. Are you guys getting it? It means what? I'm taking to the next. So if I want to I want to enter more values, it will move, keep moving forward. So I'll do what? Rear को increment कर दूंगा, rear plus plus. So this will cover. So what is happening? This is what? Insertion in a queue. So this is how insertion in a queue is happening, and this is the helping function for enqueue. Okay, great. So one thing is there. Try to get it very clear. So यहाँ पर function start 26 में हमने call कर दिया function को. Same thing we are doing that we are doing in the stack. So यहाँ पर हमने we call the function, right? And it went here. And it checked if rear is equal to size. If it is equal to size, then it will return 1 and it will print that queue is full. If it is not, it will return 0, then it will come back here and it will give the value and it will put the value there. So that is the whole thing. Okay, great. Now we will write for DQ. Now we'll write for the DQ. This is the helping function for what? DQ or deletion. You can say this way. So what I have to do? I have to write a function. Function is of integer type and is what? Q. Empty. अगर empty है कि नहीं? If it is empty, you cannot delete more, right? So that is what? A thing is. So what I have to write inside this one? तो कब empty हो जाएगा? हमने बोला कि if rear equals to size, that time it is what? Full. But when it is empty, when rear equals to become front, so that time it becomes what? It is empty. It means it here also no values there, no values there, no also values there, no values there. So it is becoming 0 0. That time what? It is empty. So what I'll be writing? What is the condition? If front is equals to rear, front is equals to rear, what will be happening? Will be returning. We will be return 1. So that will be covered in the as it's of integers type. I have to return again some value. Return URN 0. Okay. Now this is the helping function for NQ. Now I'll write the deletion in a queue. Paste deletion. Okay. So what I have to write? Void L DQ DQUE. Okay. Void DQ. This is the function. Now inside that I have to consider what? Last. What we do in queue? First in, first out. But in stack, what do we need to do? Last in, first out. So 25, if I enter 25 as the first, this should delete first. So here will be the logic will change something. So from where to delete? So I'll just call the function. I'll just call the function. If is q is empty, अगर ये empty है तो ये रिटर्न करो कि यार ये मतलब कि भरा पड़ा हुआ है, मतलब कि डिलीट कुछ भी नहीं है इसमें, तो ऐसा रिटर्न कर दो कि कुछ डिलीट कर नहीं सकते. क्यू एम्प्टी है तो क्या डिलीट करोगे भाई? यू cannot delete anything. So QUE is empty. Q is empty and you cannot delete more. Cannot delete more. So this is the thing we covered. Okay, now moving forward and then okay, great. Else part what we'll be writing? Else delete कर रहे हैं हम. कहां से delete कर रहे हैं हम? Delete कर रहे हैं first in first out है Q. So deleting from the first. So I'll be writing what? Cout DQ DEQUE DQ element is what I have to cover? First in, first out. It is deleting from where? First. That is deleting from where? Front. Front of what? Array. So what I'll be writing here? I'll be writing array of front. जब हमने delete कर दिया, now what I have to do? I deleted this one. But in stack, what we used to do? We used to delete from the top and we decrement it. But we are deleting from here, front. So we have to, because this is deleted, it means front have to, increment it, right? So otherwise we can't delete at the next element, isn't it? And then, okay. So this is done. And what I have to do? I have to increment the front. Otherwise next element will not be deleted, isn't it? So this is the whole thing. Now we will call this function NQ function and we'll just enter all the values to it. We'll just call this function, okay, and paste it. Okay, great. What is the size of it? Size is 6. So 6 एलिमेंट हम डाल सकते हैं, इसका मतलब चलो 67 डाल देता हूँ. इसको मैं कॉपी कर लेता हूँ इसको मैं कॉपी कर लूंगा, कंट्रोल सी, एंड आई जस्ट पेस्ट इट, paste it, paste it, paste it, paste it, paste it. Okay, एक ज़्यादा डाल दिया 6, and I'll change some value 98, 45, 78, 44, 45, 78. So what is the first element it came? 67. So फर्स्ट इन फर्स्ट आउट जो पहला है उसको पहले डिलीट करो, ये मतलब है हमारा। तो ये 6 एलिमेंट डाल दिया। इफ आई एग्जीक्यूट दिस वन, if I execute this one, if I execute this one, it is saying Q is Q. Why it is running Q is full every time? Did we do anything wrong? When front is equals to Q is full is running every time. Why is that? Insertion in a queue. Okay. We did something wrong. Is rare equals to return 1, return 0. Okay. NQ int value. Then is Q full. So if it is equals to size, well, Q is full. So array of rare equals to value, then we'll increment the rare. Okay, great. Now if Q is front equals to rare, return 1 or return 0. Q is empty, and you cannot delete more, and array of front, and front को delete करो and front को plus कर दो. So if I delete this one also, so why every no, something wrong, हमने तो कुछ तो wrong करा है. Yes, time is over. Okay, time is over. We'll see. Just I want to go something, every time its queue is full is running. Why queue is full every time running? Why it's not else part it is going? Because it should not, queue is not full, because size is what? Size is, I've taken 6, isn't it? Okay, line number 18, you see, I'm using here I'm using assignment operator here, double equals to should be there. Double equals to, when rare is equals to size. Okay, now I'll run it. Okay, now I'll run it. Now it is running. Okay, now if I enter here some value, so now 6 element came. Size of the queue is 6. So if I run it, so it should run properly. Now if I enter one more element, I'll change it 56 and 65 and 45. So not 45, 32. So now I entered 7. So it should say what? Queue is full. Now I'll delete this one. Delete this one from here. No, I'll comment this one. Let's comment this one. Now here if I call this BQ function 6 times, so it will delete it. Control C and Control V, BQ. Okay, great. Control C. Okay, 2 times deleting. So deleting from where? Deleting from the, okay, let's see. If I do the first DQ, let's run it. DQ element is 67. Why 67? But in the stack, DQ element was 32. If it was stacked, then it was 32, because that's the last in first out. But Q is what? First in first out. So 67 पहले आया था, तो 67 पहले जाएगा. इसका मतलब ये है. Now I write it 6 times. So 4, 5, 6. इसका मतलब ये सारा डिलीट हो जाएगा. देखो सारा डिलीट हो गया. Now what? This queue is empty. So 67 पहले गया, फिर 98, 45, 78, 45, 32. Now again if I want to delete it, अब बोल देगा queue is empty, you cannot delete more. क्योंकि array size क्या था? Array size 6 था. हमने 6 से एंटर करा था. 6 वैल्यूज एंटर्स करी थी, तो 6 ही डिलीट कर सकते, ज्यादा डिलीट नहीं कर सकते. So that is what the thing. We'll wrap up the session here. Yes guys, tomorrow we'll do pattern printing problems, few pattern printing problems we'll try to solve tomorrow. So let's meet, tomorrow. We'll, do the lots of problems tomorrow, and I'll will practicing, while loop a lot, while loop, for loop, and all those things. If you guys, then you guys can, like, it will give you more confidence. So we'll wrap the session here. Thank you guys. Good evening to everyone. Thank you all. Have a good night.